Hello, I've got a brass screw here. Now brass is an alloy of copper and zinc. You ever wondered how much copper is there in a brass screw? What percentage of this brass screw is actually made from copper? Well, that's the aim for today's experiment. So today's experiment is going to be an estimation of the percentage of copper in brass. Okay, first thing, find the mass of the brass screw. Now we know the mass of the brass screw. Now we need to react the brass screw with some concentrated nitric acid. It's 10 centimeters cubed of concentrated nitric acid. Okay, the brass screw has now dissolved into the concentrated nitric acid. So I'm going to pour this solution into the volumetric flask and make it up to 250 centimeters cubed. Using a dropping pipette, carefully make up to the mark using distilled water. There we go. Okay, now we need to prepare the sample for the titration. So first we need to take 25 centimeters cubed of the standard solution using a 25 centimeter cubed volumetric pipette. Transfer this to a 100 centimeter cubed conical flask. Okay, next we need to neutralise any of the remaining nitric acid using a small amount of solid sodium carbonate. Okay, don't need a large amount. Add it until a white precipitate just forms. A little bit of fizzing from the acid. The white precipitate has started to form. So now we need to just dissolve that precipitate by adding some ethanoic acid. Add the ethanoic acid carefully. We want that precipitate to just dissolve. There, that's got it. Okay, and then the final thing to prepare is to add some potassium iodide solution. The potassium iodide solution is going to react with the copper ions. Copper ions are going to be reduced. Potassium iodide, the iodide ions will be oxidized back to liberated iodine. So we get this brown colour, and we also get a white precipitate forming. Okay, we need to take the initial burette reading. Right, this little trick with some paper, if I can get it to focus. Helping the camera focus a bit, but also should help spot the level of the burette. Okay, you can see the precipitate has settled a little bit. So you can see the orange-brown solution swirl the precipitate, and the white precipitate gives it the cloudiness. Okay, off we go. Now we're looking for the solution is going to gradually get paler and paler and paler. As the iodine is reacting with the thiosulfate solution, it's losing the colour to form iodide ions. It's gradually getting paler. And this is where I see how brave I can be, how pale can I get it before I add the starch indicator. I want to leave it as late as we possibly can. There. I'll add the starch indicator. Now, I do need quite a lot of this. Right, so we're looking for the solution to change colour. It's quite hard to spot because some of the iodine and the starch just come out of solution and forms little white blue spots that are floating around in solution. There. That's done it. It's the end point. Record the reading at the end of the titration. The solution for the next titration. So 25 centimeters cubed of the copper solution into a 100 centimeter cubed conical flask. Add some sodium carbonate until a white precipitate forms. Add some ethanoic acid until the white precipitate just dissolves. Add some potassium iodide to liberate the iodine. Beginning of the second run. Okay, second titration. Looking for the orange colour to go to a pale straw colour. Now we're going to add some starch indicator to give a bluish black colour. It's quite a difficult endpoint to spot. We're waiting for the white precipitate to appear. Last little bit. There we go. Okay, take the burette reading at the end of the second run. Prepare the sample for the next titration. Again, 25 centimeters cubed of the copper solution. Add some sodium carbonate to get a white precipitate. Add ethanoic acid, just dissolve the precipitate. Record the reading at the beginning of the titration. Now you have your titration values, you should be able to go away and calculate the percentage of copper in that brass screw.